But first, more exciting research to come. So now we're going to have our next research flash presentations, and it's my pleasure to call up Jihad Zahir, who's an assistant professor at Cadi Ayyad University, Frederic Pivetta, managing partner at Dalberg Data Insights, and Mehi Mirpourian, senior data analyst from Women's World Banking. Yeah, go on.
Just how can I
Where's the clicker?
oh, perfect, thank you very much. Okay, thank you very much. So the topic of our project is mining the web for insights on violence against women. So the overall objective of our research was to get sense of Arabic-speaking web users towards their attitudes towards violence against women. At least in the Arab states, attitudes and social norms are still sustaining harmful practices and behaviors towards women. This is why we thought that it would be very interesting to have a tool that is monitoring these, the progress of these attitudes, specifically among Arabic web users. So to achieve our goal, our overall research objective, we had to develop a number of tools and models focusing on three complementary research axes. So first of all, we had to identify relevant data sources to our topic, and of course to develop the scripts that automatically collect the data from these data sources. Then we had a sentiment analysis component, which, I mean, we evaluate the attitudes based on the sentiment polarity of the collected content. So we had to look into this, and we had finally developed component like related to gender and geographic disaggregation of data, because generally the information about sex and location was missing in the collected data, so we had to figure out a way to identify it by ourselves. Before going further and explaining how we handled sentiment analysis, gender and geographic disaggregation, it's worth noting that Arabic language holds some unique challenges. It's highly derivational, inflectional. We have no capital letters. I mean, we have diacritics, and we lack support. It lacks support in many existing tools and packages in NLP. So it made it like sometimes it took us time and courage to develop satisfying models with satisfying performance. So I just wanted to highlight this point. So regarding sentiment analysis, our component, like we did it in two different approaches. The first approach was lexicon based. So we used available dictionaries to compute the polarity scores of our collected content. The other methodology or the other approach was machine learning based. So we had to develop our own training set. We got volunteers to annotate the items of our training set, and based on this data set, we had to develop or to train a classifier that would recognize a content that is speaking about women, and that would classify it as positive, negative, or neutral, depending on the opinion it holds. So our classifier was of a good performance, so it achieved an accuracy of 90%. Moving on to the gender identification part, we noticed that this topic was understudied in the Arabic language. So again, we had to figure out a way to identify sex of the content authors. We saw it as a classification problem, so we give to the model or to the classifier as input the text and eventually the screen name, and it had to predict the sex of the authors. So we built a training set that contains 20 8,000 item. We annotated it automatically using two name sex inference services. And these are some very few characteristics of the obtained or the developed training set. So these are some very few differences between females and males in our data set. So for example, we could see that the phrases or sentences written by males were slightly longer compared to females. We saw also that females tended to use more emojis compared to males. These characteristics and other features, stylometric features, and some specificities in the Arabic language helped us to develop classifiers that would, from text, identify the sex of the author with an accuracy of 91% and the precision as high as 97%. The other problem we had is the geographic disaggregation. So we didn't have any information about the location of people writing the text. So we had the following idea. Arabic is not, the standard Arabic is a standard that is not being, that nobody speaks natively. In the other hand, we have the Arabic dialects, and dialects generally reflect the country of origin or the location of origin. So we thought if we were able to detect the dialect in text, we would be able to resolve at least partially the problem of the location of the authors. So our problem of geographic disaggregation was transformed into a problem of dialect identification in the text. So basically we worked on on the classical categorization of the Arabic dialects. It's a categorization that is being used in the literature. So you find the Egyptian, so it's obviously the dialect that is spoken in Egypt. You have Gulf, so it represents the Gulf countries, Bahrain, Kuwait, Oman, etc. We have the Levantine that represents 4 countries, Jordan, Lebanon, Syria, and Palestine. We have the Iraqi language, and sometimes it's classified as a distinct category because it has different components from Levantine and Gulf dialects. And we have at the end the Maghribi dialect, which is representing the North African countries. So again, our dialect identification problem was a classification problem, but in 2 levels. In the first level, we had to identify the region of a text, like Egypt, Gulf, etc., the 5 categories that I just cited. And we also succeeded in having a model that could drill down to the country level for 2 regions, for the Maghribi region and the Levantine region. So we were able to see if we know that a text is from the Maghreb region, we knew if it's coming from Morocco, Tunisia, or Algeria, and same for Levantine. We were able to identify countries' appartenance in text. So in this model or in this classifier, we used a combination of 5 available data sources. We combined them, aggregated them, and done some pre-processing before using them for our models. And the generated models we had 3 models, the regional one and 2 others for the country level. And this figures show the accuracy and micro average precision for every model. The last thing we've developed was the automatic YouTube video classification, because when you the data sources we were working on were YouTube and Twitter. And when you gather videos from YouTube, you need to classify them automatically, because it would be time consuming to watch them and to do this manually. So to automate the classification, again, we had to build our own training set. It consisted of a sample of 600 videos. Volunteers had to watch these videos and to attribute labels to each video depending on the content. So we have them to inform on a number of attributes, and based on this training set, we build again classifiers that would say, if given a title and a description of a video, it would say if it's actually negative or positive, if it entails a religious discourse or not, etc. So we had a number of models. So this is very, very briefly and broadly the main components that we've developed in this project. And as a proof of concept, I'll just give give you examples of figures that we could get using our models. So this is, for example, data that we collected from YouTube using a number of search queries. So we collected 5,600 videos and more than or almost 55,000 comments written in Arabic. So the first analysis I would like to share with you is this figure. So here you can see the circles represent videos. The size of the circles is the number of views of these videos. And the colors are the position. If the dark colors or the dark circles present negative points of view, so videos holding negative opinion towards women, and the lighter ones present positive opinions towards women. Then you have the likes and the dislikes in the X and Y axis. So here what we could, while there is a predominance of positive videos, what we were able to see is that the negative videos, while they are not that much viewed, they are liked much more. So the ratio, the likes to views ratio is very important. So to us, this is an endorsement of violence, and this is an endorsement of support to behavior that is actually being harmful to women. The other figure I just wanted to share with you, from the collected comments using our sex disaggregation algorithm, we could see that 61% of the authors were male, while only 55% were females. The last maybe, or the last figure I would love to share with you is this one. So this was created using our sentiment analysis and sex disaggregation algorithm. And here you could see females and males' opinions towards 3 different topics, towards women work, women education, and women physical integrity. So we could see that the number of positive and negative opinions are equivalent, but there are some disparities between females and males. And for example, when you see for work, we were interested to see that sometimes females' opinions towards women works tended to be negative. But when we looked deeper into data, we saw that it was mainly because of the fact that it constituted an additional burden to them, because the traditional social role that they had to play remained the same. So it was that problematic for them. And I will just finish with this. Our geographic disaggregation helped us to classify the countries by their tendency to emit or present negative opinions. For example, in the Maghreb region, the worst country was Morocco, with the highest percentage of negative opinions. The first country was Tunisia. And in the Levantine region, the best country was Lebanon, followed by Jordan, Palestine, and Syria. So I'll leave it there. And if there are any other questions, we can discuss it in more details. Thank you very much.
Good afternoon, everyone. So I would like to describe, over these 10 minutes, to describe a little bit the insights that we derived from the analysis and the project that we had with Data2X. But I also would like to share maybe the journey that we had and the learnings that we derived from the work we have been doing with Data2X. And on that is going to resonate very much with the previous panel, and especially the comment from Sandy on the data cooperatives, because that's really one of the key learnings that we had on this gender work that we have been doing. And that's going to be the end point of my presentation today. But maybe first sharing who we are and what we do, so that you really see the journey and where we come from and where we want to go. In terms of context, Dalberg is a global firm, and we have I have a really a digital approach that considers data as a commodity somehow, that I want to use for certain purposes. And my purpose is to use data for social impact. And by data, I mean data from the public and from the private sector, and especially in emerging countries where you don't have a lot of high quality data from the public sector. We combine small and big data, and that's very important, because what we want to do by combining small and big data is that big data only is not going to be useful somehow to a certain extent. You always need to combine small and big data because you learn on the small data and then you expand on the big data. It's really the essence of machine learning. But obviously, what is very interesting here is that we want to scale up to a certain extent. And many people have been willing to scale up over the pilots that have been driven over the last years, but it's not easy. It's not easy because you lack a consistent and solid and resilient data ecosystem environment. You lack a kind of a platform approach. And many people have been tackling that through different forms and shapes. I mean, IDA is one, Opal is another one, and there are many others. In terms of research, as I said before, we are mixing small and big data to generate insights. And just an overview on the small data, the whole study is meant to be and to focus on Uganda. So we use, because we have an agreement with telecom operators around the globe, here we use the data from MTN Uganda, 2 months of CDRs, so call detailed records, of October 2018. We develop a certain numbers of aggregators or indicators. And then on the other side, we also made a survey, a phone survey on a random representative sample of 10,500 subscribers. The response rate was 35%. And we collect information about gender, age, who owns the phone, because that was also one of the topics that was raised in one of the previous panels, the occupational status, the sector of employment, and obviously we asked for the consent to use the data. And so, again, it's very important to underline the fact that big data as such is probably to a certain extent useless if you cannot really mix it with small data so that you can calibrate your model. The survey data help for essentially 2 goals. To build a predictive model, as I said, so basically you calibrate your model based on the survey, and then you assess also the gender gap. And that's what we observed in the phone usage in Uganda. The gender gap is around 35%. You obviously have heterogeneity across the country, and the gender gap is not really the same across the country. It differs from one sub-region to another. We also have some observations that we also obviously observe on the on the big data sets, and that helps somehow to parameterize and to see what were really the relevant variables to somehow separate men from women in the call detail records from the telecom operators. So in a nutshell, what we did is that we looked at the call patterns of everyone, and just based on the call patterns and the survey data, we infer who is a woman and who is a man. Obviously, there are different dimensions that matter. You have them listed here. I listed them afterwards as well. Women have longer incoming calls. Women have more outgoing activity. Women have less top-ups. Women have fewer calls. Women top up with smaller value, and women travel less. Because, as was pointed out before as well, you can also understand the mobility patterns. That's what Nuria was talking about before, using the call detail records. So what you can also see is that urban and younger profiles show less difference between men and women. Age is the key differentiator for social networks. The rest you can see already in what I said before. We also asked questions and we also collected data, on mobile money. And basically, one of the key differentiator was that men tend to transact a little bit more than women. So that's one of the observations that we had as well in the mobile money data that we collected. Then we built, using machine learning, we built a gender predictive model. And the approach, as I said, is machine learning. The objective is to predict the gender for all individuals in the telecom database. It can serve as a basis for future sex-related programs. And that's something, that's one of the key learnings, and I want to share that with you in a minute. The training, we train different models. You have the models on the right-hand side. I'm not going to go into that. But basically, the idea of the different models is that you have like different models, and then you train them, and you pick the models that predict best the outcome. Okay, and the different models, it's basically here, it's a very simple modelization, which is you classify the data point either being a woman or a man. So it's like it's really binary somehow, and based on a series of variables. And as I said, the key variables that we observed in the data are the average top-up value, the count of unique contacts per active day, average call duration during the week, the radius of duration. That's the radius of duration is the mobility, basically how far do you go, and the average duration of an incoming call. So these are basically, you look at these variables from every individual in the telecom data, and you can predict based on these variables whether it's a man or a woman. The predictive power here is between 72 and 75% in Uganda. We also have been running that type of model, not exactly that one, but that type of model in Bangladesh, and we end up with 84%. So the predictive power is going to differ between countries based on a series of elements, and one element is the cultural context. And what we suspect is that in Bangladesh, the cultural segregation between women and men is bigger than in Uganda, so it's basically easier to differentiate between women and men in the telecom data. Going forward, and a few key learnings that I want to share with you. So as I said, we developed that with GSMA, and we basically implemented a similar but different approach in Bangladesh to try to predict gender. Another learning that is very important is what's next, basically. And one example of what's next is trying to predict the woman empowerment. So here, we just try to predict the gender, but another thing that you would like maybe to predict on a very granular level is it a woman, and is she economically empowered? Meaning, and the economic empowerment you can define different ways. I mean, in what we are doing now in Uganda, we try to define economic empowerment in do you own a land, or do you own a house, or do you participate or take the lead in the financial decision making of your household? Things like, do you have a job, and if so, what type of job? So you see, we try to, you need really, the next level probably of insight is to start mixing the gender and something else, because just knowing the gender is interesting, but if you want to be actionable, you need something else. And that goes to what Sandy was talking about, which is we start also thinking of building an entire data ecosystem. Here is an example of what we have been doing in Ethiopia for gender and the labor market. But I'm sure we can do that and replicate that in many countries, and that's a top-down exercise, meaning that we have been collecting data ourselves. And that leads me to the final point and the final learning about data trust, because I truly believe, as was pointed out earlier, that having a form or shape of data cooperative is probably the future to basically decrease the cost of accessing the data, involve the people at individual level, and scale up basically what we have been doing here and what everybody has been doing over the last years on data and gender. And it's a kind of a natural way to move forward, but it's hard because developing, at least to me, developing a data trust or data cooperative requires a lot of dimensions to align. It's going to be governance, it's going to be business model, it's going to be commercial model to a certain extent, etc., operational processes, etc., etc. So it's not easy. But I truly think that's the future to be able to scale up this kind of approach. Thank you very much.
Good afternoon. This is Mehi Mirpourian. I'm working as a senior quantitative researcher within Women's World Banking. And today I need your help. Why? Because I have just 5 minutes to talk a lot. So I need attention. There's no time to go back. As you can see, the title is From Account Ownership to Account Usage. We collected data from Nigerian microsavers and run a study that I will explain step by step. So I said Nigeria, a country which is located in West Africa, more than 200 million in population, very young, median age is 18, and it has mainly two seasons, dry and rainy season. And if you look at the financial inclusion based on 2017 Findex, 49% of men and 73% of women have no financial account. And that's what we are working on, financial inclusion, bringing more women, basically closing this gender gap. The research question, we want to find factors that affect the transaction size. It may not be, you may think that it's not very clear, but it gets clearer, hopefully, at the end. Okay, we collected more than the information of more than 86,000 microsavers during July 16 to 18, 2 years. And surprisingly, these microsavers, majority of them are low-income people. However, inside that low-income population, you see that 4.4 population, mainly men, contribute to 80% of all transaction amounts. That's sad. It means that there's a very small portion that does most of the transaction. So when you have this situation, you think that probably, if you think as a kind of, from statistics point of view, the mean and median in this population should be significantly different. And we want to make a predictive model for two purposes. One is prediction and also for statistical inference, to understand what's going on, what are the factors that affect the transaction size. So we said, okay, if we want to make a predictive model based on mean, it's not fair and it's not correct also. So what's the solution? And I call this problem mean trap. Let me explain a little bit more. When we started this project by funding of Data 2X, we had two goals. One is to provide some feedback to the financial provider who creates this micro-saving program and help them to better serve low-income people, and also bring some contribution to the literature, doing something new. But besides that, also we wanted to have a message for the public. Some people are data scientists, many of us, and some are not, have no interest in data, but they are interested in this topic. So that's where mean trap comes. Why I call it mean trap? I said mean is not a good indicator. So, and we are trying to help low income. So it's mean to use mean when it's not a good indicator. That's why I call it mean trap. And in this 5-minute presentation, if I can do something really good, no matter you are interested in data or not, whenever you think about, you have to make a decision to think that, is mean average a good indicator? Is it a trap for people that I want to help? That's the only thing I want in 5 minutes. If I can do, I was successful. So I said, mean is not a good indicator. We started working with another method, which is called quantile regression. It's not new compared to other data science methods like neural network deep learning, but it's pretty new and it's getting more attention in recent years. And what are the findings? So we included a couple of variables in our model, but for the sake of time, I just focus on 3 of them. The first one is age. If you look at what you see on the plot above, the first plot, you see that as age increases, we expect the transaction size per each transaction gets larger on average. Someone in the crowd may say, Mehi, hold on. In the previous slide, you said mean trap, and now you report information on mean? Said, no, hold on for a second. Say, okay, look at the bottom one, the information from the quantile regression. So what if you just look at the average, you see that as age increases, transaction size increases, and that based on that, we can make some policies or give some feedback to the financial service provider. But they say, for those who make the first percentile, which is basically 10th percentile, the lowest, age has no effect on transaction size. And if you go to those who make the largest transaction, the last one, you see that age has negative impact. What does it mean? It means that those who make larger transactions, they tend to be younger. That's why I brought both of them to show that mean can be misleading. And also, if you consider the gender gap, you see that for the largest percentile, the negative impact of age is 3 times larger on women compared to their men counterparts. The other variable that we included in our study is seasonality effects. And I like this one a lot. Why? But we figured out that for both men and women, they both tend to make much larger transactions in dry season compared to rainy season. you may say, okay, that's interesting, but so what? I say, okay, this is an optional saving program. It means that if you have money, you save. If you don't have, you don't. So there is no obligation there. And it means that they have, we can say that there's a high correlation that they have higher income in dry season. And most of the credit products, I mean loan products, that they ask low-income people to pay back within a year in fixed regime repayment. And here you see that under no pressure, they have, it shows that it has, they have more, they can do more savings, so probably more income in dry season. So maybe a flexible repayment regime can be a solution for credit products. That's one of the usages. And the last one, I put it more deposit or more withdrawal. That's the question. And you may say, why that's the question? I say, because they are low-income people, they usually don't have any saving, and we try to encourage them to save, because when you have saving, I don't want to go into the benefits of saving, but they have some savings, they can go for micro insurance, they have health insurance, credit products. And if you look at average again, what you could see that no one saves in long term. But if you go quantitative regression, the approach we took, you see that just those who basically make the smallest transaction size, they tend to do more deposit than withdrawal. More deposit than withdrawal, it means more savings. Who? Those who make the smallest transactions. And the last one, I know that I'm out of time, sorry. Practical implications, I put them here. I don't go to details, just again, think about mean trap. And finally, I want to say that this work, I'm here to present it on behalf of Women's World Banking, but it was not just me. First of all, I would like to thank Data2X for funding this project. And besides that, my colleagues, Kate Glean, Broderick, and Anna Thier, and Mayan Kumar, they were great help in doing this analysis. Thank you very much.
Thank you so much. Am I on? Okay. Thanks so much to all of our panelists. So we have a little bit of time for some questions. I can see. Okay, I see one. Okay, we'll start with Riddhi.
Thanks very much. Thanks very much for these really interesting presentations. I'm Riddhi Kashyap from the University of Oxford. I wanted to come back to the presentation. In fact, this is also something that was in the earlier, in the panel that I was speaking in as well, with about mobile sharing, SIM sharing. And I wondered if in the presentation on it was Uganda, I think. Is this something that you noticed in your data set as well? And you know, you obviously had to do sort of a prediction task, but if you have SIM sharing, as Claudia was saying, that could be a problematic issue. So I'm just interested to hear what your impressions are on that problem.
Is it? Yeah. So on the SIM sharing during the survey, one of the questions was, and if the answer was yes, I am sharing my SIM with someone else, or I am not the main subscriber on this number, we stopped the call. So we were just focusing on people who are really using mostly, I would say, 80% of the time their phones. So that's for the survey side. On the CDR side, we have an algorithm to correct to a certain extent for multi-simming and for SIM sharing, but it's hard to, as my colleague was saying, as a person from FlowMinder was saying, it's really hard to correct for fully for the SIM sharing. So yes, it's going to be a bias that we will need to live with. Yeah.
Great. Any other questions over here?
Thanks for those presentations. I'm Sean Higgins from Northwestern University. This is a question for both Frederic and Mehi. We saw in both of your presentations kind of a difference between men and women in a number of measures of use of either mobile money or micro savings accounts. Do you think there are also kind of gender-specific barriers to using mobile money and savings accounts? And can the type of big data that we've been seeing used here today help us to document those barriers and document the impact of potential solutions to those barriers, or do we need other types of data and interventions to measure that?
Yeah, I think that's a point that was made before on monitoring and evaluation. I think from Catherine from Gates Foundation, who are saying that we are still at the basic level in terms of we are trying to understand, to observe, and to evaluate. We are not trying to find the root causes at this stage. I think that's what we see in the data. We just basically see that men are transacting more than women or larger amount than women, but we don't know why here. I mean, here at my level, just looking at the data, I cannot come up with like a root cause somehow.
I would say that's a great question. In our organization, the research team has two parts, quant part and qual part, for the same reason. Because what I can see in large data sets, let's say huge data sets, I can find a good pattern. If I do my job very good and the data is good, I can find a pattern. However, at the end of the day, in most cases, I don't say always, in most cases, I can say why. And that's why we have qualitative research. So it goes more to kind of social science and other approaches, but using, I would say, big data, sometimes yes, but necessarily you cannot always say why. But you can see something, you can detect a pattern, if there's a pattern there. But for reason of pattern, that's another story.
Back there.
Thank you. I wanted to ask the first presenter whether in the work on attitudes towards violence against women, whether other presentations have talked about the sort of ground truthing the results against existing indicators on the ground. I wonder if there's if the data you've collected through your mechanism can similarly kind of be tested against some of these indicators on attitudes on the ground, whether it be from DHS surveys or other instruments. Thank you.
Okay, and before, let's take one more over there.
Yeah, just wondering, gender not being binary, how much more money would you need to be able to really study human gender so that you were studying male, female, transgender, like just kind of looking at all of humanity, and so that we could just have gender be defined broadly? I'm curious about like what kind of funding increase so we could collect all of that and start understanding more.
From my perspective, it's not very different from what we are doing here. Here, indeed, from a technical perspective, it's easier to have like binary just to sort out men from women. But I think that we are advanced enough technically to go a step further. So in terms of funding, it's not much more than what is already allocated for this kind of research, I believe. But it's really like my assumption and intuition. I don't think it's going to be like a dramatic increase. Not a lot, I would say.
And a related question is, there's probably more difference within the genders than between them. And so have you also done stuff where you're looking at behaviors across and other kinds of things?
So first, I'd like to go back to your previous question. I say that, again, I know it's on record, but I prefer this was not. For this part, I just say my thought that if we want to go, let's say, when we you talk about gender, usually in these studies it's like male and female. So what about others? I think in terms of technical barriers, it's not a big barrier. I agree. I think in so many countries that we are working internationally speaking, it's a kind of more norm and culture barrier in some contexts. It's not more technical. Talking about this issue, still it's not like everywhere like here. So there are areas that is kind of a problem if you want to talk about those things.
And let's give Jihad the last word.
Yes, to answer the question, we've done the exercise, especially for the classification of countries, and it's consistent with the reality because Tunisia in the North African region is considered as progressive with regards to women's rights, followed by Algeria and Morocco. So it's consistent with the reality. However, this was a proof of concept, so we didn't work on a representative sample. So now when we are going to, this is coming up. I mean, when we will work on a representative sample, we will be more, this exercise will have more sense, like validating with the truth and with the real results coming from traditional source of data and methodologies. Yes, thank you.
So thank you so much again to all of our researcher presentations. Now it's my pleasure to call up Karen Howe for the next panel. You'll have more opportunities to ask your questions, though, during our coffee break after this next panel and at our reception later on today. Thank you.